CRISPR.
This is Oxford Circus, one of the most central parts of central London. When you look around, what do you see? Lots of cars. Cars emit CO2 through the combustion of fossil fuels within the engine. In processes like this, humans produce in excess of 38 billion tonnes of CO2 annually. Scientists agree that this is having a profound effect on the temperature of the atmosphere, sea level rise, and ocean acidification. As I'm sure you know, CO2 is known as a greenhouse gas as it prevents heat from radiating away from Earth. The presence of these gases is necessary to keep the planet warm enough for life. However, build-up of these gases can cause global climate change. It is known that urgent and effective action is needed to combat the effects and causes of the build-up of carbon dioxide.
For science!
Luckily, plants can help us. They play a tremendous role in what's known as the carbon cycle. They perform a chemical reaction which we call photosynthesis, where they absorb carbon dioxide from the atmosphere to create glucose, which they use to grow and reproduce. This is fantastic. All plants absorb carbon dioxide from the atmosphere. But there's a catch. Every time the plants want to use the glucose, or when animals eat the plants, or when the plants decompose, that glucose gets turned back into carbon dioxide, which goes back into the atmosphere. That's why it's called the carbon cycle. Now, most photosynthesis is done by plants like this. However,
40% of photosynthesis is done by phytoplankton in the ocean. These microorganisms use photosynthesis to convert CO2 dissolved in the water into glucose, much like plants. This not only reduces the level of CO2 in the atmosphere, but also directly reduces the acidity of the sea, as the CO2 reacts with water to form carbonic acid, which reduces the pH of the water. This harms marine organisms such as coral, which become bleached when some of their enzymes denature. Unfortunately, just like plants, phytoplankton gets eaten and the CO2 is released back into the sea. The ultimate problem is that any process plants use to reduce CO2 from the atmosphere is then reversed. We need a way of trapping CO2 in permanent carbon sinks. That's where CRISPR comes in.
CRISPR, clustered, regularly interspaced, short palindromic repeat. This is the name of an immune response in some bacteria. It involves the CRISPR-Cas9 enzyme that is, in effect, able to read DNA. If it detects a section of bases that it recognises as a foreign DNA from a virus, it can alert the bacterium to attack the virus. As I'm sure you've heard, researchers have already successfully used CRISPR techniques to edit microbial DNA. Our proposal is to use the technology to alter the photosynthesis in some phytoplankton. We would cause them to produce a chemically identical isomer of regular glucose, known as L-glucose. There are no known organisms on Earth that can digest L-glucose, except one. This would mean that the L-glucose that they produce alongside conventional glucose would be excreted, unused in the ocean, where it will remain forever. This will create an ever-enlarging carbon sink that will trap carbon dioxide from the atmosphere permanently. As with all things, there are some issues to be overcome. Firstly, we do not yet know what effect this glucose will have on marine life, if any, and we are not likely to learn any more about this. Further, there is no known organism that produces L-glucose by photosynthesis, so the DNA we use to create this in phytoplankton will have to be artificially engineered, something which we are not currently able to do. Despite this, our proposal not only presents a practical and sustainable solution to all the adverse effects of carbon dioxide in the atmosphere, but it also creates a biochemical challenge that should be overcome and would mean huge developments in a wide range of fields, including medicine.
For science!
CRISPR.